Welcome back to Math Quest. So hopefully by now you've mastered how to solve one-step equations. Now we're going to work on two-step equations, simply adding one more step. So two-step equations means that you will have to perform two different operations to solve the equation. So it can be a combination of addition and multiplication, subtraction and division, and so forth. So let's get to it. Let's look at these examples. All right. Well, let's take a look at the first example that we have here. We have 2x plus 9 equals 21. Now, previously on the one-step equations, I asked you to identify your coefficient first, okay? Because that's what we were going to be dealing with. But in this case, you have to identify your constant. Constant is just a number without a without a variable. So the opposite of a coefficient. So my coefficient is 2, my constant is 9, but there's also another constant here, which is 21. Well, basically, if you can remember that, you want to get x by itself. So let's get rid of the 9 and the 2. But in this case, we're not going to get rid of the coefficient first. We always get rid of that last. So let's get rid of our constants. And we're going to do the opposite here, okay? Inverse operations, which means if it is plus 9, I gotta ask myself, what is going to make this equal 0? Well, if I have a 9, how do you make it equal 0? You take away 9, right? So that's where we're gonna start, by taking away 9. I gotta take away 9 here. So let's take that away. Obviously, I know that this is going to make that equal 0. That's what I wanted to accomplish. So on this side of the equation, remember, this is my equal sign here. Okay, my equal sign still remains here. So this side of the equation, I have 2x. That's left here. And here, I simply have 21 minus 9, which is going to be 12. Now, this looks just like the one-step equations we were doing previously. So you should know by now that all you have to do is divide both sides by the coefficient. This is my coefficient right here, the 2. So I divide both sides by 2. 2 divided by 2 is 1. 1x equals 12 divided by 2, 6. So the value of x in this exercise is 6. Remember, check your answer. Do not ever forget to check your answer. 2, notice 2x. So instead of the x, I'm going to plug in a 6. So 2 times 6 plus 9 equals 21. So basically, I'm saying that now that I have a value for that variable, if I solve what's on this side of the equation, it should equal what's on the other side of the equation. So 2 times 6 is 12, and 12 plus 9 is 21. So 21 equals 21. My answer checks out. Excellent. Let's try another one. Okay, so here we have 7 minus 4x equals 22. This right here can get a little tricky, so I need you to really pay attention to the values, meaning are they positive or are they negative? Okay, so let's get started here. So first, I know that 4 is my coefficient, this 7 is my constant, and the 22 is my constant. So I'm going to start with the 7 and the 22. I don't want to subtract 22 here. I know it's a positive 24. I can subtract and make it a 0. But I'll leave this side blank and move everything to this side. Remember, I want the x to be by itself, so I want to get everything away from the x. Okay? So let's start with the 7. It's a positive 7, so how do we make it a 0? By taking away 7. Okay? And I have to do it to both sides of the equation. So on this side, I'm taking away 7. And on this side, I'm taking away 7. Okay, so I know this is going to equal 0. 22 minus 7. Well, that's going to give me 15. Okay? Equals, well, what is left on this side of the equation? It's a 4x, but I want you to pay close attention because this minus sign belongs to that 4. Okay? So I have to put it here. Oh, so now I'm dealing with really essentially a negative 4. Okay? Now, let's proceed with this one carefully. I have negative 4x equals 15. Well, I'm going to take my coefficient here and I'm going to divide both sides by it. Notice I'm dividing by negative 4 on both sides. Negative 4, because that belongs to that 4. Negative 4 divided by negative 4 equals a positive 1, a positive 1x. And this here, 15 over negative 4, will simply, there's nothing more I can simplify here because they don't have any common factors. So I can actually leave my answer like this, or I can change it to a mixed number. If I change it to a mixed number, all I have to do is simply divide. So if I want to divide, it would be my negative 4 as my divisor and my 15 as my dividend. So 4 goes into 15 3 times, and that would be 12. Now, don't focus right now, oh, that would be a negative 12. No, I'm simply dividing here. That's all I'm doing. I'm just converting it to a mixed number. Gives me a remainder of 3. This is the beauty about converting it to a mixed number, that all you have to do is divide once, and I'm done. My answer is right in front of me. Okay? So I asked myself, how many times did the 4 go into the 15? Well, it went 3 times. That's my whole number. Right there, that's my whole number. My remainder of 3 becomes my numerator. And the number I was dividing by becomes my denominator. Now, I'm not going to write negative 4 here because this whole value is negative. So therefore, I'm just going to put the negative out in front. And my final answer is x equals negative 3 3/4. Or x equals negative 15 over 4. Okay? Or 15 over negative 4. All right. Let's try one more. Okay, so now we have 18 excuse me, equals 1/5 times n minus 7. Okay, so right here I can see my minus 7 is my constant, and 18 is another constant. 1 over 5 is my coefficient. Remember, if there are any constants here on the side of the variable here, I want to get rid of it. So I notice here we have a minus sign here. So I don't want you to think of this as just a 7. Think about it as a negative 7. And how can I make this equal 0? Well, simply by adding 7 to it. Okay, that's on one side of the equation. So let's do the same thing on the other side of the equation. So this minus 7 and plus 7, of course, we know equals 0. That's what I wanted to accomplish. And we have 1/5 n. That's what's left on this side of the equation. There's my equal sign. Bring it right down. And now I have 18 plus 7. That's 25. All right. Now, let's solve this last step. Multiplicative inverse rule. Have you heard of that before? All right. I hope you have. So we have 1/5 times n equals 25. So we're going to multiply by the reciprocal of 1/5. So here we have 1/5. On the other side, we have the 25. And there's my n, of course. But right now, I just want to write the reciprocal of 1/5 on both sides. Okay? And of course, there's my variable, my n. Now, this 5 divided by 5 is 1. 1 divided by 1 is 1. So I'm left with 1n. I have my equal sign. This, of course, so you can visually see what it is that we're doing. Remember, you can always write a 1 over or under any whole number. Now we have 5 times 25 and 1 times 1. Well, this is just going to equal 1, but 5 times 25 equals 125. That should be the value of my variable n. So 125. And once again, you can plug it in to check your answer and make sure that it is correct. All right. I lied on that last one. I told you this was going to be the last one. I have one more for you. Here we go. Okay, so here's our final one. Just a little word problem on how we can actually use these two-step equations and multiple equations from there on, you'll see. So Chicago's lowest recorded temperature in degrees Fahrenheit is negative 27 degrees. Wow. Solve the equation negative 27 equals 1.8 times C plus 32 to convert to degrees Celsius. Well, this should be rather easy because they already wrote out the equation for us. Okay, so all we have to do is use our fancy skills that we used in the previous examples so we can solve this one. So let's write it out here. Negative 27 equals 1.8 C plus 32. Okay, now if we remember correctly, we can see right here this 1.8 is next to a variable, so that makes the 1.8 the coefficient. The 32 and the negative 27 are my constants. Now the question is, which one am I going to get rid of? Which one do I want to make it equal to 0? The negative 27 or the 32? Well, since I want to get the C by itself, the variable by itself, I want to get rid of the 32. So let's go ahead and do that now. A positive 32, I know a negative 32 would make it 0. And of course, whatever I did on this side, I must do it to the other side of the equation. So that's negative 32. Okay? So this equals 0. So what I have left on this side of the equation is 1.8 times C equals, now here, be very, very careful. We have a negative 27 minus 32. That means we're taking away another 32. So essentially, I'm going to end up adding these. Okay? So this will equal 9. This will equal 5. And the answer is still negative. Negative 59. Okay. Last step. I find my coefficient. And I know to get that variable by itself, I must divide both sides by my coefficient. So let's do that now. Divide here by 1.8. Divide here by 1.8. 1.8 divided by 1.8 equals 1. 1C. There's my C. And 59 divided by 1.8. This is going to get me a repeating decimal. So it gives me 30. What happened here? 32. Okay, it doesn't want to write. Here we go. 32.7777. So since the 7 is repeating, I'm going to stop it here at 0.8. I'm just going to round to the nearest tenth. Oops. You know what? It depends on what the instructions say. This one didn't give us anything specific. So actually, instead of doing that, I can just do this right here. 32.7 repeating. That's my bar notation over the 7, which indicates that the 7 is the only number that repeats. And now I know that negative 27 degrees Fahrenheit is equal to 32.7 degrees Celsius. So hopefully now you know how to solve two-step equations, and I'll see you next time as you continue on your math quest.